How's everybody doing today? Good, good, good. Um, yeah, I'm super excited today. I don't think I'll take up the full 2 hours, but I think this is a fun topic. Well, maybe not a fun topic to talk about, but something I think we all have to talk about at some point. So I'm really excited today to talk about migrating your app from Objective-C to Swift. Just getting all my windows set up. So, like Angie said, a little bit more about myself. I've been doing iOS development for 10 years. I run my own company called BrightDigit, where I do contract and subcontract, mostly Swift development by and large. I have my own podcast, empowerapps.show. I'll have some links to some episodes that you might find helpful, where I talk about this particular thing. And then I also have some videos. I've been doing videos of the podcast, video interviews. So that's on there. And hopefully I will have maybe some videos on this topic in the near future. So we'll see about that. And then if you want to check out any of my libraries or open source work, you can check that out on GitHub at the address in the slide. So what are we going to be talking about today? First of all, we're going to be talking about why this is more important more than ever in 2020, and why this is really an important topic to talk about. We'll also be talking about different ways of migrating, whether we want to do it piece by piece or whether we do an overall rewrite of a particular part of your application. And then we'll be doing a walkthrough of the piecemeal migration of a basic just UI table view controller app that's written in Objective-C, how we migrate that over to Swift in the best way possible for the stability of your app. Starting off with optimizing the existing Objective-C in your application, and then we'll get into building a pure Swift layer and how to do that. And then we'll get into building a compatibility layer between your pure Swift to any Objective-C that might consume that code. And then lastly, the most fun part, deleting all that old Objective-C code when that's ready for you and how we'd go about doing that. So let's talk about why this is an important topic and why we should be doing that. I'm going to move my windows over. Let me know if you can still see everything. Everything looks good, folks. I just want to make sure you can see all our slides. Are we good? Oh, screen sharing is paused. Chat. Cool. Glad to hear that you can see everything. So why do we want to do this? Come on. I'll put this right here, actually. Yeah, that's better. So why is this important? So for one thing, there's three components I see as to why this is an important thing for folks who are building an application and why they want to migrate to Swift. There's the optimization of your application, the maintenance of it, and the API availability of certain APIs that Apple has been putting out in the last couple of years. So as far as maintenance, I mean, I don't know, Angie, but like, you do like recruiting, right? Is that correct? Or you help with recruiting at Atomic Robot, right? How easy do you think it would be to find somebody with an Objective-C expertise in 2022? It's probably not that easy to do. And also, like, the new hotness, obviously, is stuff like SwiftUI. Like, people don't want to do Objective-C if they don't have to, most new developers. Now, there's obviously older developers who have been entrenched in the Apple ecosystem since Objective-C has been out in the 90s or whatever. But, like, most of your new young developers out there, they want to jump right in and use the newest APIs that are out there, especially with, like, SwiftUI, right? That's been really popular lately. There's also optimization. There's not a lot of work being done by Apple. There's no open source team like there is with Swift for optimizing these apps and making them faster. Like, as far as iOS is concerned, like, all the new technology when it comes for developers is all in the Swift space. So we just don't see a lot of growth there when it comes to Objective-C. I'm not going to like debate that compile times are going to be better on Objective-C. We all know there's reasons for that and why that might be. But as far as like the optimization of your app, the future really isn't when it isn't in the space of Objective-C development. And so that also goes to our last and probably I think most important point, API availability. Any new APIs, a lot of new APIs have been coming out in the last couple of years are Swift exclusives. And I'm talking about stuff like Music Kit even, or Widget Kit, which is dependent on SwiftUI, Swift Package Manager, you're still stuck using CocoaPods, Reality Kit, Store Kit 2 stuff, Crypto Kit, Care Kit, and Combine, of course, which is aligned with SwiftUI, but also the new Shareplay stuff with group activities is all completely Swift. I went through the whole documentation. There's surprising parts of things that work in Objective-C, but there's a lot that just Apple is not going to be coming out this year with new APIs in June 2023 that will support Objective-C necessarily. There's definitely no guarantee of that. So that's really something to think about. So our discussion today is really how do we how are we going to migrate an old application that still has Objective-C code over to Swift, and how are we going to do that? And there's really a couple ways we could do this. Most of all, you want to start with unit tests. You want to make sure you have solid unit tests set up. We're not going to deep dive into that in this talk, but mostly I want to just have that in mind. As with any new code, always make sure you have code coverage set up correctly. And then when it comes to the two ways of doing it, you can either just fully rewrite that part of the architecture, or you can do it piecemeal. And it really depends on the particular code and your application. Is this kind of a good timing anyways to do a redesign of the UI or a re-architecture of your underlying API? Because in that case, it might just be worth going whole hog and redoing the whole architecture in Swift if that's the case. But if there's like multiple implementations, like for instance, you have a protocol and it's implemented in various places throughout your application, then maybe a piecemeal approach where you still have your Swift code available to Objective-C callers, it might be worth having that piecemeal approach. Like going back to the redesign, if you're going over to SwiftUI, it might be a good time to like move over and do a rewrite of the whole UI layer of your application as well over to Swift. Are there already places where you have the Objective-C code being called by Swift? In that case, maybe a piecemeal approach might work better. Or removing old OS support. Again, like there's a lot of deprecated code where it might be worth just rewriting that over to Swift rather than doing individual pieces. Do you still need to support older OSs? And in that case, a piecemeal approach makes more sense. So what I want to do right now is we're going to go and do like a step-by-step approach on how to piece by piece replace pieces of Objective-C code and move them over to Swift. And we're going to do that in a step-by-step process. First, we're going to optimize the Objective-C code, and we're going to make sure that it's fully integrated and ready to go over to be consumed by Swift in the best way possible. We're going to build a pure Swift layer that doesn't really care about Objective-C compatibility. And then we're going to go ahead and build a bridge between that Swift code over so that it can be consumed by Objective-C. And then lastly, once we feel comfortable, we'll then remove that Objective-C code from your application so that it's completely in Swift. And then we profit because we don't have to spend so much money on maintaining an application still written in Objective-C. So let's talk about the app first. We have this classic phone app. We have an old phone in the background there, so back when phones were phones. And then we're going to go ahead and we are going to have a very simple app. It has a UI table view controller, all written in Objective-C. And then it will be able to pull the data from a facade or repository where it'll get members, and then it'll just basically add those members to a table view controller. Super simple. I didn't try to do anything complicated here. It looks something like this in a nice iPod Touch. simulator, just a basic table view controller. We grab the items from the facade, and then we store those members, and then we grab each member in the array, and then we set up the text and text color based on the member. Hopefully some folks kind of understand what's going on here. In this old Objective-C code, I had to refresh myself when I was writing this sample app. But yeah, super simple. We've all written table view controllers and rendered them out in Objective, well, at least in Swift. We have a member and a facade. The facade just returns, it's a async call, so we have an array of members, or the error if there's something wrong with like the network call or the database call or whatever. And then we have a bunch of properties of the ID and the name and all that stuff that we pulled for the member. We have some tags. We're using Objective-C, an Objective-C enum or options here, which has multiple tags for the member as far as what they're interested in. That's about it. It's a pretty simple app. I didn't try to make it very real world because I want to keep it simple. But we're going to now take that first step and optimize the Objective-C code. And what I mean by that is there's a lot of issues with Objective-C and Swift interop because of the way, you know, Swift is a strong typed language. It expects you to have everything, you know, defined, well-defined, and working the way it expects. So there's not a lot of ambiguity like there is with Objective-C, and it's just different philosophies in how the languages work. Specifically, we're talking about nullability and generics. So let's go over nullability first. So when you have Objective-C piece of code that you're going to consume in Swift, one of the things that you run into is we don't have the concept of optional. Objective-C didn't care. Like, you as the developer needed to check that yourself using some sort of if statement to see if an object is nil or not. So here we have our facade call for getting members at the top, and we have the completion handler. We have the members and errors that are returned that you specify in the block. But there is no indication as to whether any of those objects are optional or not. So you get back all these exclamation marks, which basically means you don't know whether they're there or not, and you have to check yourself in Swift, which is really kind of annoying because you can crash your app, obviously, if you assume something is not nil and it is. Again, we have a bunch of these properties here. We have no idea whether any of these properties are going to be nil or not in Swift. So if you look at like the autocomplete here, it's all exclamation marks because they're implicit unwrapped optionals, which is something that, you know, sometimes you rarely ever want to run into when it comes to Swift. And they're kind of a no-no in a lot of ways with a lot of code. So we can actually fix this Objective-C code so that way we can specify what Swift should expect. And we do this using some really cool ways. So on properties, for instance, under the attributes here, you can specify whether something is nil or not nil by using the non-null or nullable within the property. And then that way now, like for instance, for things that are nullable, like the details, or for instance, the ID, we know that'll never be null. We can specify that in the property here. And now when we do autocomplete, we actually know for a fact whether certain things are going to be, could possibly be nil and might not be nil. Going back to our facade, for instance, also we can do that. We can do that with both the completion handler as well as the parameters that they expects in the block. So we can go in and we can say that instead of having all these implicit unwrapped optionals, we go in and we mark these by non-null and nullable within the parameters of our method, as well as you could do this in the return part of the function or method, excuse me, as well. So that is all available to you. Typically, you want to do this in the header, these things in the header file of your Objective-C type. But once you've done that, now, like when Swift consumes this, it'll know for a fact. And as a matter of fact, just something to point out: if you do this anywhere, it will expect it throughout that header file. So you can't just do it at one spot. You'll get warnings throughout your code if you only do it in one spot. Or so you could either say, hey, I don't care in some instances. There's some attributes for that. But if you do it at one spot, it'll expect it everywhere throughout that header file. So we've talked about nullability. I kind of knew this early on. Yeah, that's right, Andy. There's the NS assume as well. Yep. So I knew about nullability early on because one of the big language features of Swift that for Objective-C developers was something you had to wrap your head around was optionals. But something that they brought in later, like I think a couple of years ago, was actually generics. I didn't know generics was actually supported in Objective-C, but that's really going to be really helpful. And that comes in with our call here for the facade, where you have get members. So we have this get members call, right? And we get back an any, but like it's going to be a pain in the butt for us to do an if-let for every single item within that array and then have to figure out, oh, it's a member. Like we have to cast it, we have to call if-let calls and things like that. But luckily for us, we have the ability now to specify the type within any of these like collection types like NS array, NS dictionary, things like that. And all you have to do is put the angle brackets here with member in this case and the member pointer. And now when Swift calls this, we'll know for a fact that we're actually going to get back members, which is really nice. And it's going to make it a lot easier for you to call your Objective-C code. So that I think is a really awesome addition. Again, it has to be in your header files. Once you've put it in your header files, then you're good to go. And now you'll know exactly what types you have. And I think this is a good first step for any of your code base that still has Objective-C. Even if you're not ready to like necessarily migrate it to Swift, I think this is a good first step. Because when you do migrate it to Swift, at least now you know what to expect from these calls that you are basically redoing in Swift. So the next step I want to talk about is building that pure Swift layer. And this is brand new code that won't necessarily care about how it's consumed in Objective-C. You want to take advantage of Swift to its best advantage. To its best abilities, because this code will eventually be the code that you're going to use in your application once you get rid of your Objective-C. So if there's certain patterns like delegates that you just don't really need in Swift, then this is your opportunity to use whatever new, like functional programming or functional reactive programming or whatever patterns you're into in Swift that you really couldn't do in Objective-C. This is your chance to do it. So for instance, here we have our member, which had to be a class. It had to derive from NS object. We can use a struct because a struct makes more sense in this case. We can, in this sample, I'm not going to do any advanced codable code. So instead I created a intermediary struct called member response for that JSON code. But that's in there. And then also we, with our facade, we've migrated that over. We can now really take advantage of a result type here. And so we're doing that. We're creating, we're actually having a result type, which is not available to us because tuples really don't exist in Objective-C or these enums with associated types. So now we can do that here with our repository type that is in pure Swift. So there's a lot of things you can do that you have available to you in Swift. This is the time to use it. So don't do it in such a way that you're worried about Objective-C. So things like structs, advanced enums. You can do enums with raw values in those will be consumed in Objective-C, but anything that is going to use associated types or don't have raw values, you can't do that in Objective-C, but that's okay. You can use that here. So your result type, which is like an enum basically behind the scenes, tuples, the new stuff with async and await, take advantage of it. Generics, real generics, advanced protocols. You don't need class. It doesn't have to be a class. It doesn't have to derive from NS object. You can use optionals. Take advantage of those things. This is what this layer is for. Do it in the best Swift way possible. So once you've done that, the next step then is building an Objective-C compatibility layer between your pure Swift code and the Objective-C stuff that is going to actually consume it behind the scenes. So here is where you're kind of building a bridge between this pure Swift layer and the Objective-C code that's going to be consuming it. And because you'll run into issues, right? Obviously, I said do it in the best Swift way possible, but things like structs aren't available in Objective-C. Integer optionals aren't available in Objective-C. Any sort of enum that it can't be consumed by Objective-C, like tag here, is not going to be available. So what we're going to do now is create a type that will wrap around your struct and that will do any of the translation needed for Objective-C. So here we have a class I called it deprecated member. You call it Objective-C member. You can call it whatever you want. And it's going to wrap the struct member and provide any work that needs to be done so that your values and properties are available in Objective-C. So in this case, color value, like the int, optional int there, it's not available. It won't translate even with Objective-C members here. So I translated it to an optional NS number, and then that worked okay in Objective-C. The tags, for instance, I'm just going to use strings in this case. It really depends on your situation how you want to translate those enums, but you're going to want to do that here so that it's available to you. One thing to point out, Objective-C members will take everything in your type and make it available in Objective-C. That it can. If you want to specify individually, you can use the at Objective-C attribute to do that as well. So if you need to make anything available in Objective-C, it has to be a class, it has to derive from NS object, and it has to have some sort of at Objective-C attribute on it so that it can be consumed by Objective-C. Again, we have our repository protocol. It has a result callback. That's not available to us, obviously, in Objective-C. So I created some extension code here that will allow me to be able to have that consumed by Objective-C. So then what I did is I went ahead and wrapped that in an object and converted that over so it doesn't have to require result type as well. I'm going to address some questions right now. So, Andy, as far as I've seen, I've had to derive from NS object. I know it has to be a class type, but I don't think it's consumable. I'll double check that. But I know from the times I've done it, I've had to derive off of the NS object. Will you be covering Swift class extensions to Objective-C files at some point? It's another way to do. Maybe we'll talk about that one, Vu, after the talk, because I'm interested to hear what your thoughts on that. But yeah, just going back to my slides, result type, that's a switch, an enum, not available to us because it has associated types. So then we have kind of just running the same patterns that Objective-C expects with the two nullables, one for the error and one for the actual value. So the compatibility layer will have to be able to translate things like structs, enums, result types, tuples, generics, optionals over to an available type that using, like, if we have to extend an NS object, or we have to use NS number, or we have to tag it, obviously, our types with Objective-C in order for them to be available to us, because it's not automatic. I think they stopped that in like Swift 4.2 or something. It was a while ago that you have to basically mark things as with the Objective-C attribute in order for it to be available. Otherwise, it's not going to be available at all, even if you do all the right things with your type and your code so that it technically should be. But this is here where you're going to create that bridge. What you want to do, again, you want to isolate the pure Swift code away from the Objective-C and just create a bridge for that, so that at some point, like I said, you'd be able to remove this compatibility layer, and you still have Swift code that is optimized for Swift in an isolated manner. So we have our deprecated member, call it whatever you want. That is basically that bridge, and then you're just going to go ahead and use your new type, and it's going to be seamless because it'll act just like your old Objective-C type did before. So that's building the Objective-C compatibility layer. Once you feel comfortable, then you could start looking at really hacking apart a lot of your Objective-C code and then like converting it over. Just looking at the project that this is based on, we have things like their table view controller. You know, it really depends on your situation. You could just convert that over to Swift and stick with UIKit. You can move it over to SwiftUI, but you can move over your app delegate. Maybe you just want to use the at main stuff that's new, or whatever OS you support. You can just go ahead and move that over, and now we can just remove all that old Objective-C code, all our old deprecated stuff over. And now you have a pure Swift application available to you. That's mainly the guts of my talk. Some resources that might be helpful. I did a couple of episodes where I really deep dived into this. The way Ray Winderlich team had put out a book called Expert Swift. One of the sections are on Objective-C and some of the stuff we talked about with the different attributes dealing with nullability and generics and things like you can rename types so that they're named differently when they're consumed in Swift. And the video as well as the podcast episode is there if you want to check that out, where Shai gets into that in the episode. And then I actually did recently a whole episode on Objective-C with Graham Lee, talking about kind of the history of Objective-C and why it is the way it is. Really interesting. A lot of stuff about how the type systems are different. Definitely want to check that out if you really want to get the background and a history of Objective-C. And then I actually did a blog post about upgrading apps and the different ways of doing it, more in a higher level way, and why sometimes you want to do a rewrite, sometimes you don't. You can check that out at the link there. And then there's also the repository for this code. It's all set up in such a way that each step is defined in a separate branch, so you can definitely check that out as well, where in that GitHub link, and I will post that. I don't know, whoever is going to be consuming the links and the slides, I'll send that over. So after this talk. And lastly, Apple has some really great documentation on this where they really deep dive into importing not only Objective-C but also C stuff as well. So that link has a lot of what I talked about nullability and generics and how to import code, both using Objective-C code but also using Swift code and bridging headers and things like that. So you'll definitely want to check that out. So what did we talk about today? We talked about why, even especially now in 2020, why it's super important to start actively getting rid of your Objective-C code where you can, especially if you're going to be consuming new APIs, because it's just going to be, especially if you're running a big team, it's going to be a lot tougher to get the old Objective-C code maintained. So now's the time to do it. Whether you want to do a full rewrite or you want to do it piece by piece. And some things to think about there. And then we went into the step-by-step process of doing a piecemeal migration that is starting off optimizing your Objective-C code with nullability and generics, building a pure Swift layer that takes advantage of Swift and whatever patterns you want to do in Swift that you can do now in Swift that you couldn't do in Objective-C, building a Objective-C layer that uses actual Objective-C patterns, but in such a way that it can be deleted at a later point, and then removing any remaining Objective-C code once that's done. Thank you so much for attending this talk. I'm really happy to do this. This was fun, and I am looking forward to taking those questions.